Number 15, there are 200 milligrams of bacteria in the pool. Once a chemical was added, the bacteria decreased by 0.5 every single minute. You're going to write an exponential growth. It's not a growth here. It's an exponential decay for this problem because it's decreasing. Okay? Exponential function to represent the situation. We know that the function is y is equal to a parentheses b to the x power. Here it says there are 200 milligrams of bacteria, 2,000. So that's your a value, 2,000 milligrams. Then we add it, and it's a decrease. So it's going to be a decay. So it's 1 minus. Okay, so the b is 1 minus r. We just need to know what r is. R, it is 0.25. Okay, so b is equal to 1 minus 0.25, which is just 0.75. That's it. So y is equal to 2,000 parentheses 0.75 to the t for time. Here it says how many bacteria is in the pool in hours. Please understand that this is decaying every single minute, okay? So time is equal to 60 minutes, okay? Because the decay rate was in minutes, so you have to make sure this is also in minutes. So let's just plug in t in for 60, okay? So this is the function. We have 2,000 parentheses 0.75, and then the exponent is going to be 60. And whoa, that's a super small number here, right? So wow. So we can say that is about 6.37. And do you see this? It shows like times 10 to the negative 5, okay? So times 10 to the negative 5 milligrams, all right? This is a classic problem that you're going to see in your bio class. So I wanted to show you this, okay? So there you go.